Good evening, everyone. This is the second part of the discussion, and this part I will discuss the structure questions related to Block 2 test. So, in question 21, complete the sentence with the word that describe the main process of thermal energy. A man goes for a walk on a cold day. He touches a metal gate which removes the thermal energy from his hand by. So whenever two objects are in contact, how the energy transfer? The energy transfer is by conduction. So energy remove or energy transfer is by conduction. Then he holds a side of a cup containing a hot drink. His hand gained the thermal energy. So how his hand will gain the thermal energy from the sideways from the surrounding, because again it is in contact. Whenever two objects are in contact with each other, that is also conduction. And some farm workers have lit a fire. The man warms his hand on the side of the fire. His hand gains thermal energy by radiation. If he places his hand up top of the fire, it means that will be radiation and convection. But because sideways, then it is only radiation. Describe in terms of particle the transfer of thermal energy through a metal of a gate after transferring from man's hand. So what will happen? The particle vibrate, because you have to explain the conduction here. So the particle vibrate and also electron travel from a region of high temperature to low temperature. So particles vibrate and electron transfer from region of high temperature to low temperature. And that is how the conduction happens. Figure 5.1 shows a car on a sunny day in a hot country. The windscreen object A is there. The object level A is placed inside the windscreen. That is the sunshade, you can also say. So it is used by the owner of a car to reduce the temperature rise in the air inside the car, which will reduce the most. So it should be a shiny and a white surfaces, because dull and black surfaces are good absorber. We don't want to absorb too much energy, so it should be shiny and white. And what is the reason for that? Because shiny and white surfaces are poor absorber and good reflector. So as a result, when the heat energy is coming from the sun, so most of it will be reflected. So the temperature of air inside the car will not rise too much. Next question, define specific latent heat of fusion. So energy needed to change the state of 1 kilogram solid one kg solid without into liquid without changing temperature. So without changing the temperature, if we are able to change the state, we call that, like whenever there is a change in state, there is no change in temperature. And when solid is converting into liquid, it's called fusion, and liquid turn into gas, we call that as vaporization. The next part, a small piece of ice at zero are added to 0.35 kilogram of water. Initial temperature of the water is 24.5. The temperature of a water decreases to zero. The water loses 35,000 joules of energy, and ice is all the all of the ice added to the water melts. The specific latent heat of fusion, we need the specific heat capacity of the water. So we have the formula C is equals to E divided by M delta T. So the energy which is lost, that is 35,000 joules. The mass, as I mentioned here, that is 0.35, and the temperature change, originally it is 24.5 and then it becomes 0, so it will be 24.5 minus 0. So when we simplify, we'll get the specific heat capacity, which will be joule per kilogram degree centigrade. So it is 4100 joule per kilogram degree centigrade. Then we have to find the mass of the ice added. So what is our assumption here? That all of the energy which is lost by the water is absorbed by the ice. So 35,000 joules of energy lost by the water is all absorbed by the ice. And we have the formula latent heat is equals to energy divided by mass. So mass is energy divided by latent heat. Energy is 35,000, where latent heat dimension 3.3 into 10 power 5. So this will be 3.3 into 10 power 5 kilogram. So when we substitute, it will come out as the mass will come out 0.11 kilogram. That is the mass of the ice which is melted or added to this water. Next question. So pollen particles are mixed in liquid. They are seen moving when observed through a microscope. Describe the movement. So what kind of movement they will have? They will have a random movement, or they will have a random motion, like they will not move in a specific direction. They will continuously changes their direction. So we call that as a random motion. Then explain this movement in terms of molecule of a liquid. So molecules of a liquid continuously colliding with the pollens. The pollen particles exert force, cause random motion. So basically what is happening, because these molecules of a liquid, they're continuously moving, and they collide with the pollen particles, and this collision exert a force and they cause a random movement or random motion, you can also say. A medical professional sometimes rub ethanol over the skin of a patient. Ethanol evaporates readily, like quickly, and room temperature and high specific latent heat of vaporization. State whether the patient experience heating or cooling or neither. So what he will experience, and explain your answer. So he will experience a cooling effect. And what is the reason for that? Because the ethanol molecules absorb energy, gain energy from the skin, and evaporate, and they will absorb greater amount of energy. As you can see, they mention high specific latent heat means greater amount of energy is absorbed to change the 1 kilogram of substance. Then state any effect on the rate of state an effect on rate of evaporation of ethanol. If air is blowing, so the rate of evaporation will increase. Then a machine delivers a hot drink in a plastic cup, which is uncomfortably hot to hold. Figure 5.1 shows a cup for a hot drink. Then figure 5.2a shows a cup with a hot drink and a holder is there. As you can see, the holder, this is a side view and this one is a top view. So there's an air gap between the holder and the cup. Explain how using the holder make it more comfortable. So using a holder, basically air is present between the holder and the cup, and air is not good conductor of heat energy, and it will reduce heat transfer by conduction or convection, because you're not directly in contact. That's why it will reduce the heat energy transfer by conduction or even convection, you can mention. A student carry out experiment on the cooling of hot drink, described in a without the holder in place. He find that the holder only reduces the rate of cooling slightly, like it cool down when holder is there, it cool down, so relatively faster but not too much different. Suggest and explain another action that reduce the rate of cooling. So what you should do, you want to reduce the rate of cooling, so you should put a lid or use a lid, and what will happen, it will reduce rate of evaporation or heat loss by convection. Convection current cannot occur. That's why it will reduce the heat loss and it won't cool down quickly. State a method of thermal energy transfer from start through the vacuum. So in a vacuum, the only way which energy can transfer, that is known as radiation. Conduction and convection both require the particles to transfer. In question 25, figure 4.1 shows a thermometer. As you can see, look, this is a thermocouple as they ask here. So 5.4 millivolt. According to question, it's 5.4 millivolt. So 5.4 millivolt, and what is the temperature difference? 0 and 100. So when the temperature difference and the voltage produced, so temperature difference is 100 degree, the voltage produced is 5.4 millivolts. So the first part they are asking, state the name of this type of thermometer. So what we call this as a thermocouple. And the second part, figure shows a thermocouple. So now the voltage reading is 1.7. So if the voltage reading is 1.7 millivolt and one of the junction is at 20, what is the temperature of this? So when voltage produced is directly proportional to temperature difference, not temperature of the other substance, temperature difference between the two junctions. So now the voltage is 1.7 millivolts, so the temperature difference will be x. Cross multiply. So when we cross multiply, it will be 1.7 multiplied by 100 divided by 5.4. So this will come out as 31. So 31 degrees is a difference in the temperature. So one of the junction is at 20, so the other junction should be at 51. So that the difference in the temperature between the hot and the cold junction is 31. To calculate the temperature of liquid X, so temperature of liquid X will be 51 and the temperature difference between the hot and the cold junction is 31 degrees centigrade. So the voltage produced by a thermocouple is directly proportional to difference in the temperature. So this was about the thermal physics test, block 2.